Hello students, welcome back in this tutorial video. It's me Dipendra and Shrestha, science teacher, and today I am here with the remaining part of pressure lesson of class 10. In previous video we discussed about the Archimedes principle. Archimedes principle means thrust gained by the object is equals to weight of displaced liquid whether the object is partially or completely immersed. Last time we discussed about that. And today we are here with the law of flotation. Law of flotation. That is a special case of Archimedes principle. So today we are going to discuss about law of flotation, verification of law of flotation, conditions of floating of objects, atmospheric pressure, mercury barometer, some applications of atmospheric pressure like a syringe, air pump, hand operated water pump, etc., which you have to read in this lesson, pressure. Okay, before starting the law of flotation, let's discuss about the conditions of floating of an object. Already we have discussed when the density of object is less than density of liquid, then object floats. You know, piece of wood floats, ball floats on water, but iron sinks. Stone sinks. So, substances which have less density than density of liquid, that floats, and which have more density than liquid, that sinks. You know that. You have read in lower classes. Have you seen used ship which is floating on the sea, ocean? Is that made of plastic, wood, like this? No, there is part of iron also. There is iron also. So, huge iron ship made of iron easily floats on the water. We say those objects which have more density than water sinks. Density of iron is more than water. When we put a small iron nail in water, it sinks. But a huge iron ship carrying with the large amount of cargo, with the large number of people, easily floats. How is it possible? So, there are two conditions for floating of an object. One, already we have discussed, if the density of object is less than density of liquid, then it floats. Okay, conditions, one condition, first condition, if the density of object is less than density of liquid, then it floats. You know that. And another one is related to the law of flotation. Related to law of flotation. If an object is able to displace the liquid, displace the water equal to its own weight, then it also floats. Once again, if an object is able to displace the liquid, displace the water equal to its own weight, then it can float. It is possible to float. Although the density of object is more than liquid, although the density of object is more than water, but if it is able to displace the liquid equal to its own weight, then it can float. So, two conditions for floating of object. One, if density of object is less than water. Another, if an object is able to displace the liquid or displace the water equal to its own weight. That is, or in that situation, object can float easily. So, law of flotation states that an object can float on liquid if it is able to displace the liquid equal to its own weight. Or you can say floating object displace the liquid equal to its own weight. That is called law of flotation. Floating object displaces the liquid equal to its own weight. That is called law of flotation. So weight of floating object and weight of displaced liquid are equal. If the object is floating on water, at that time the weight of that floating object and the amount of water displaced by that floating object is equal. So, law of flotation, don't forget, frequently asked in your exam, floating object displaces the liquid equal to its own weight. Floating object displaces the liquid equal to its own weight. So, iron ship, you know, an iron nail sinks in water, but a huge iron ship easily floats on the sea. Why? That is related with the law of flotation. You know, iron nail, shape of iron nail is very small. You know, density of iron is more than water. So, while keeping this iron nail in water, it cannot displace the water equal to its own weight. That's why it sinks. Iron nail cannot displace the water equal to its own weight, and density is more than water. That's why it sinks. But ship is made in such a way that it can displace the water equal to its own weight. Ship is made in such a way that it can displace the water equal to its own weight. It has a wide base to get more upthrust. There is a hollow space which decreases the relative density, because of which it can easily float. So remember, iron nail cannot displace the water equal to its own weight. That's why it sinks. Ship can displace the water equal to its own weight. That's why it floats. Okay, frequently asked in your exam, very important, reasonable question. An iron nail sinks in water, but huge iron ship easily floats. Why? Yeah, you know, density of iron is more than water. Iron nail cannot displace the water equal to its own weight. That's why it sinks. But huge iron ship can displace the water equal to its own weight. It is made in this way. That's why it can easily float on water. Okay, so don't forget law of flotation. Floating object is equals to weight of displaced liquid. Okay, floating object is equals to weight of displaced liquid. A floating object displaces the liquid equal to its own weight. So while swimming, to float on water, we have to displace the water equal to our own weight. If we are able to displace the water equal to our own weight, then we can easily swim on water. We can float easily, according to law of flotation. Verification of law of flotation. One experiment, we are going to show that weight of floating object is equals to weight of displaced liquid. One verification. Okay, you know, this is top and balance. It measures the mass or weight. Here is Eureka can. It's a beaker, yeah, glass beaker. And here I have taken one bottle. Okay, bottle. It is made of plastic, so it can float on water. That's why I am taking this as a floating object. Now I am going to use this bottle. So we are going to show weight of floating object is equals to weight of displaced liquid. For that purpose, first of all, I am going to measure the weight of empty beaker. Okay, weight of empty beaker. Let's check how much is this. Weight of empty beaker 160 gram. Okay, weight of empty beaker here. Okay, verification of law of flotation. Verification of law of flotation. We have measured weight of empty beaker. Weight of empty beaker equals to how much? 160 gram we have found. And another one, I am going to measure the weight of this floating object also. Okay, weight of floating object, how much is this? So here I have found 110 gram. Okay, 110 gram. This weight mass of this floating object is a floating object I am going to use. So this bottle's weight is, or bottle mass is weight of floating object equals to 110 gram. You can write 1.6 Newton, 1.1 Newton as a unit of force or weight is Newton. You can write that. Okay, now after that I'm going to pour the water in this Eureka can. Okay, we have to measure the weight of a Eureka can with water in this top and balance. Let's measure. How much is this? So here we have found about 210 gram. 210. Okay, 210 here is. So we have found weight of Eureka can with water equals to 210 gram, 2.1 Newton. Now I'm going to immerse the floating object. Okay, I'm going to immerse the floating object. And this displaced water. When we immerse the floating object in water, surely displace the water, and this displaced water I'm going to collect in this beaker. Okay, let's put here. So look at here, while immersing this bottle in water, water is displacing from Eureka can to beaker. Okay, Eureka can to beaker. Eureka can to beaker. Now, after immersing this floating object, again we are going to measure the weight of Eureka can and this weight of displaced water separately. Okay, according to law of flotation, weight of floating object is equals to weight of displaced liquid. So we are going to discuss about that. So let's check it. Okay. So now we can measure. So here weight of Eureka can water with a floating object. It is 210 gram. You can see 210 gram. That means weight does not change. Even after immersing the floating object, even after immersing this bottle into the Eureka can, weight is constant. Weight is constant. So after adding the bottle also, weight remains same. Weight remains same. So here we can write weight of Eureka can with water and floating object equals to 210 gram. It means 2.1 Newton. Remains same, don't forget this. So, floating object displaces the liquid equal to its own weight. Yeah, floating object displaces the liquid equal to its own weight. Before immersing, before putting the Eureka can also 210 gram. After putting this floating object bottle into the Eureka can also 210 gram. How it is possible? Because floating object displaces the liquid equal to its own weight. So how much weight was this floating object? 110 gram weight. That is displaced by the floating object. If we measure the weight of this displaced water, if we get that 110 gram, then it will prove. Let's check. So weight of displaced water with a beaker, here we have found 270 gram. 270 gram. You can see here 270 gram. So let's write weight of beaker and displaced water equals to 270 gram equals to 2.7 Newton. It means only weight of displaced liquid or displaced water equals to weight of empty beaker 160 gram, weight of beaker and displaced water 270 gram. So weight of displaced water only 270 minus 160 gram. So equals to how much? It means 40 and 70, 110 gram equals to 1.1 Newton. Look at here. So weight of displaced water 110 gram and weight of floating object also 110 gram. So according to this we can write weight of floating object equals to weight of displaced liquid. Yeah, we got this. This is the law of flotation. So law of flotation is verified. Look at here. Weight of empty beaker 160 gram. Weight of floating object 110 gram. Weight of eureka can with water 210 gram. Weight of eureka can with water and floating object also 210 gram. That means after immersing the floating object in water also weight remains constant. That means same result we got in the top and balance. Similarly, weight of beaker and displaced water 270 gram. Weight of displaced water only, this is empty beaker, displaced water, beaker plus displaced water minus empty beaker, that is also 110 gram. So this is 110 gram is weight of floating object, weight of displaced water and floating object also 110 gram. Same result we got. It means weight of floating object equals to weight of displaced liquid. This verifies the law of flotation. So every floating object displaces the liquid equal to its own weight. Or if any object is able to displace the liquid equal to its own weight, then it can float. This is the law of flotation, whether the density is less or more. Okay. So up to here we have finished. After this we are going to discuss about the atmospheric pressure. Okay, we have finished Pascal's law, Archimedes principle and law of flotation. Okay, we have finished Pascal's law, Archimedes principle and law of flotation. Now we are going to discuss about second part, atmospheric pressure. This about the atmospheric pressure we discuss in the next video. So watch it, like it, comment it. We will meet in the next video. Thank you.